We have here an example of a Java program. Okay, so this has main methods, so you can run this. This is executable. And in here, we declared a one-dimensional array with the name imp, and it has 3 elements. So we have imp0, we have imp1, we have imp2. These are the 3 elements as specified in the size here in the declaration. So remember that this part here, the left side of the assignment operator, is the purpose of that is to declare the array with the name imp whose elements are type integer. And then on the right side of the assignment operator, starting with the new operator, the purpose of this side is to allocate RAM or memory spaces to the 3 elements, which are this emp0, emp1, and emp2. And then after the declaration in this line, we set initial values. Emp0 is set to 100, emp1 is set to 101, and M2 is set to 102. And then we simply display them on the screen, one line each, because we use println. So that's why the output is 100 for emp0, emp1, and emp2. We may also declare multi-dimensional array. And how do we declare multi-dimensional array? It is by defining more than one pair of square brackets. And then we are able to also initialize with values in curly braces similar to a one-dimensional array. Let's take a look at these examples. Now, how many square bracket pairs are there in the first declaration? We have here 1, 2, and 3, right? So this is an example of a 3D array or a 3-dimensional array. And in the second syntax example, we have how many pairs of square brackets? We have 1 and 2. Therefore, this is an example of declaring a 2D or 2-dimensional array. So we have here some examples. Say we are going to declare this array 1 as an array of 3 dimension, and each element is type integer. And then we use the new operator to specify the memory spaces to be allocated for array 1 having this dimension sizes. So the first is size 3, first dimension, second dimension size 3 also, and the third dimension size 3 also. If we're going to visualize this 3D array, okay, so this is a 3D array. So if we're going to visualize that as a 3D object, it would look like this one. This looks like a cube, a 3 by 3 by 3 cube. And the first size here refers to, in this cube, this refers to the number of rows. And the second size refers to the number of columns. And the third size here refers to the thickness of the 3D object, of the cube. If we let I to be the row index and j to be the column index and k to be the thickness index, then your I would be from 0, okay, that's the default starting index. So I would be from 0 to 2, your j would also be from 0 to 2, and k would also be from 0 to 2. So I is 0, 1, 2, j is 0, 1, 2, and k is also 0, 1, 2. There are 3 indices for I, 3 indices values for j, and 3 indices values for K. Since I is the row index, I would be equal to 0 in here and 1 and 2 in here. If you cut this part here, then the top part is the first row, or when I is 0, and when you cut this part here, the middle part, which is this, is the second row, or when I is equal to 1, and the bottom row is the third row, or when I is equal to 2. This one in blue color, the top is the first row, and the green color is the second row, and the yellow color is the third row. For the column index, J is the column index. J is equal to 0 in here, J is equal to 1 in here, and J is equal to 2 in here. So when you cut this part here, this is the first column, or when your J is equal to 0. When you cut this part here, this center here is the second column, or when J is equal to 1. And the rightmost column, which is this color yellow, is the third column, that is when J is equal to 2. For the thickness index, K is the thickness index. K is equal to 0 in here. So when you cut this part here, the front part is when K is equal to 0. When you cut this part here, the green color, the middle is when your K is equal to 1. And the back part here, which is the yellow color in here, that is the third thickness, or that is when K is equal to 2. So this is K equal to 0, K equal to 1, and this is K equal to 2. Now another example we have here is a 2D array. So this second example in here is a 2D array. Array 2 is a two-dimensional array because you have two pairs of square brackets and each element is type integer. Now, what we are using here to allocate memory space is using an initializer or using an initialization list. So, how do we know the sizes of the two dimensions? By looking at the list, we have here first element, second element, and third element. Now, by default, the RAM or the memory of the Intel-based computer, it used the row major ordering of elements, meaning the elements are in row-wise order. This first element here, and then comma, second element, comma, third element. This is the first row, and this is the second row, and this is the third row. And in each row, there are three elements. So this refers to the number of columns. So since there are three elements in the outer level of the initializer, it means that there are three rows. Okay, row 1, comma, row 2, comma, row 3. And in each row has three columns. So it has three columns since each row has three elements inside. So this is a 3 by 3 array. So array 2 would look like this, a 2D array of three rows. Okay, this is, say if the row index is I and the column index is J, then your I is from 0, 1, 2, and the column index J is 0, 1, 2 also. So this is when I is equal to 0, this is when I is equal to 1, and this is when I is equal to 2. This is row 1, row 2, row 3. And for column, this is when J is equal to 0, this one here. This is when J is equal to 1, and J is equal to 2. So row 1 is this part here. The initial values are 0, 1, 2. So this is 0, 1, 2. And for row 2, this part here, this is row 2. The values for row 2 are 3, 4, 5. So this is 3, 4, and 5. And for row 3, the values are 6, 7, 8, 6, 7, 8. So if you are going to access array 2, 1, 0, what would be the value of array 2, 1, 0? Your I is 1, so it refers to that. I is 1. And then the column J index is 0, so it refers to that, the intersection. So this is equal to 3. So the answer is 3. Array 2 indices 1, 0 is equal to 3. And array 2, 2, 1, this is array 2, 1 is 7. Here we have another example, a Java program where we declare a 2D array. So this line here is a declaration of a 2D array. Okay, as you can see, there are two pairs of square brackets, 1, 2. So this is a 2D array. And the initial values of the elements is this one. Okay, so how many rows and how many columns are there? As you can see, we have here the first row, and then we have a comma, second row. So this is row 1, and this is row 2. And each row has 1, 2, 3, 1, 2, 3 elements. So this has 2 rows, and this has 3 columns. So this is a 2 by 3 2D array. And if we're going to represent this as a table, this has 2 rows. This is our row 1, and this is our row 2. If we let I to be the row index, then your I is from 0 to 1. And if we let J to be the column index, then J is from 0 up to 2. Why 1? Because there are 2 rows. By default, the index starts with 0, and so it ends with 1. And the column index would be having values 0, 1, 2, because there are 3 columns. This is the first column, J is 0. Second column, J is 1. Third column, J is equal to 2. And this is the first column, column 1. This is column 2. And this is column 3. This is your row 1 when I is equal to 0. Your row 2 is when I is equal to 1. Your column 1 is when J is equal to 0. Column 2 is J equal to 1. And column 3, J is equal to 2. So if you're going to access A00, A being the array name, A00 is this one, right? It is 5. Okay, remember this is row 1, and so 5 is here, 3 and 8. For row 2, the elements values are 6, 2, 9. So this is 6, 2, and 9. So when we are going to reference A00, okay, when I is 0 and J is 0, it refers to this. When I is 0 and J is 2, it refers to that. When I is 1 and J is 1, it refers to this element. Okay, so A00 is 5. That's the output, okay, for this println. And A01 is 3. So that's the output.